Hey everyone, this time we're going to do second part of scientific notation. This time we're going to change scientific notation into a standard number, or they call it standard notation. So what you would consider a regular number. Now remember, I cannot write exponents on the whiteboard, so instead of writing the exponent, I put that upside down tiny v to show that's the power of -9. So that is 10 to the power of -9. And what you want to do first is write your decimal number, so 6.08. So there's my 6.08. And then I look at my exponent and it's a -9. That means I need to move 9 spaces. The negative tells me this number is going to be a small number. If it was positive, it would be a large number. Or you can remember that if it's negative, then you're going to move to the left, okay, to go the left direction. So I'm going to go the left direction the same number of times as my power. So 9 times, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Just enough room. And that's where your new decimal goes. Okay, so there's my new decimal. All these 8 spaces are just going to be filled in with zeros. Okay, just because remember, the power means that you're multiplying or you're dividing by 10 to make the number bigger or smaller. Okay, so if I'm to rewrite it, 0. And now I know right here this is going to be 8 zeros. I don't even have to count them because I had to move my decimal 9 times, and I moved it once for the 6, and then I had to add 8 zeros. Sorry, my nose is a little stuffy. I just sneezed like 10 times before I started this. So I'm going to write my 8 zeros. 5, 6, 7, 8. Not the prettiest. That's okay. You get what I'm doing. And then the 608. And that's my final answer. Okay, so this is changing the scientific notation into a standard number. Let's try another one on the opposite end now. So let's do a large number, 6.78 times 10 to the power of 12. Okay, so same as before, I want to write my decimal number first. And this time I have a positive 12, so instead of going to the left, this time I'm going to go to the right, because that's going to make my number larger. Okay, if you're unsure, just start moving your decimal and go, oh, that way my number is getting smaller. If I went this way, instead of 6, it would be 0.6, right? But if I went from here to here, it would be 67. Okay, so 12 spaces. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 in a decimal. And then I'm going to fill in these spots with zeros. And I know it needs to be 10 zeros because I moved 2 decimal places to start, and I had to move a total of 12 total. So if I subtract the 12 minus the 2 I already moved, that would leave 10 zeros for me to add. So if I count them, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, plus the 2 spaces I moved initially. There's my 12 spaces. So if I rewrite it, 6, 7, 8, and 10 zeros. 1, 2, 3. It's a lot of zeros. 4. Really should use the circle tool. 6, 7, 8, 9, and 10. And then if you want, my 10th one came out wonky, so I'm going to get rid of that one. If you want, then you can add the decimals. So after every 3, not decimals, commas. After every 3 spaces, add your commas. Okay, so this would be 6,780,000,000,000 of something. Okay, let's try a different one. So I'm going to move my slides. Okay, this time we have 4.90 times 10 to the -6. Okay, so back to a negative this time, so I'm going to write my number again as always. So I'm going to write 4.900, and I have to write it exactly. Those zeros are there for a reason. Those are significant digits. Okay, so these are significants. I can't get rid of them. Okay, and it's a negative, so that means we're going to move to the left, or we're going to make our number smaller. Okay, so remember, a negative number becomes smaller. We move to the left. 1, 2, 3, 4, 5, 6. I counted from my decimal place like normal. And add zeros, 2, 3, 4, and 5 zeros. So when I write this, I need to write those 2 zeros at the end of the 490. Those are important to my number. So I have 5 zeros here. 1, That was ugly. Why am I suddenly going the other directions? Because I can't write on this thing today. Some days you can write, some days you can't. I did really well yesterday. Not so well today. It's okay. And then I need those 2 zeros at the end because those are significant. Okay, so this right here, those are your significant digits. Okay, so if you look at this number you just made over here, okay, and if you looked at the significant digits, it would still be the same part right here. That's what would be significant. It matches up with your scientific notation over there. Okay, let's try one last one. 5.00 times 10, times 10 to the power of 3. Okay, so this is another one that it has all these significant digits. So it's 5.00 is my original decimal, and I'm going to move it 3 spaces. Now this time it's going to be to the right because it's making the number bigger because it's a positive number. So I want to go 1, 2, and 3 spaces. And this is my new decimal place. Now look where that decimal is. If I just write this 5,000, that means only the 5 is significant and these zeros would not be significant, and I would cross them out when I'm counting my significant digits. But look at the way it was written originally. It was 5.000, meaning these 3 zeros are significant. And how I show those significant digits is I keep that decimal place right there. If I keep that decimal place, then all of a sudden these zeros are significant and it matches up with the significant digits over here. That I had 4 sig figures over here, I had 4 sig figures over there. Okay, so it matches up. So my answer is not 5,000, it's 5,000 with a decimal place at the end. And that is changing from scientific notation to a standard notation.